Hello, good day. Welcome to another episode of Learn Smart with Fitola saying sorry I've not been posting in a while. It has not been easy. I've been caught up with work here and there, end of the year, beginning of new year, meetings here and there, and it has not been easy. And as a matter of fact, NEPA people have been doing a strong thing recently, and I'm very sure you are hearing the background noise of generator. That's just what I could result into in the end. I just had to do the tutorial, and this tutorial I'm going to be doing it on the fly. I did not prepare a script or anything. Usually I prepare scripts for my tutorials before uploading, so that it's going to flow very well. So pardon me if I don't really flow so well. I'm just recording it on the fly because there's no time to start preparing scripts, and preparing a perfect video anymore. So just pardon this video. Thank you very much. So today we're going to be treating application of differentiation, and it's going to be very fast and very smooth. I would not want to waste too much of time. Now there are many ways with which differentiation is applied, but I'm just going to explain a few of them. Now first and foremost, let's consider this graph. Now you realize that at this point you see that the equation is increasing, right? It's going up. At this point it is reducing and goes like that and on. And you see that at this point it is stationary at this point, and it is also the turning point of the equation, right? Same as this side, the turning point of the equation. Now if I give you a question like y equals x squared plus 4x minus 1, and I told you to tell me if this equation is an increasing equation or a decreasing function, how would you know it? You would have to first plot this on a graph before you could tell, right? But no, not anymore. You wouldn't need to plot this on a graph to be able to tell. So for example, now is this equation an increasing equation or a reducing equation? Now we can use the idea of differentiation. If you do the first derivative of any equation and it is greater than 0, then it is an increasing function. And if you do the first derivative, it is less than 0, then it is a decreasing function. And if it is 0, then it is stationary at that point. It is stationary at that point. Now let's try this. dy dx for this one equals 2x plus 4. Now the question might go this way: is this increasing at where x is 2? So now all you just need to do is put that inside here, then it equals 2 times 2 plus 4, then that's 4 plus 4, and that's 8. Now we can see that this equation is an increasing equation where x is what? 2, because obviously here it is what? Greater than 0. So you might see a question like, is this equation an increasing function at where x is this, or determine whether it's an increasing function at just, how they will set their question, and that was that. Now the question might go this way: okay, this same equation, but at where x equals to minus 5, is it increasing or decreasing? Is it an increasing function or decreasing function at that point? Then after you have differentiated first time, what you just have to do is input that's 5, 2 times minus 5 plus 4, that's minus 10 plus 4, then that's minus 6. So since it is minus 6, which is less than 0, then we are sure that at this point, at where x is minus 5, it is decreasing. So this way we can easily tell with differentiation. This is one of the applications of differentiation. We can easily tell if a function is increasing or decreasing. Okay, now, and just like I said, if it is exactly 0, then at that point it is stationary. It's just like this point here. It is stationary at that point. These 2 points here, stationary. So let's take for example now let's determine if this function is stationary or is increasing or decreasing at where x equals -2. So firstly, like we said, do the first derivative, that's 2x plus 4. Now by the time you put -2 plus 4, that's -4 plus 4, which is what, 0. Since it is 0, then it is stationary at that point. Good. Now, like we said earlier the other time, at stationary it is quite easy to tell if a function is increasing or decreasing, right? Like here it is increasing, we know that it is increasing at that point. Like here it is decreasing, we know it is decreasing at that point, and it does not coincide with, you know, some other points. You would always get it that way. But then you realize that increasing the stationary points can occur at two places, right? It can occur at the maximum point, it can occur at the minimum point. Now, how would you be able to tell? For example, now based on what we treated last, if and where x equals to -2, you know, by the time we did it the other time, we got that it was stationary, isn't it, at that point at where x is -2, right? So at this point it is stationary, and since it is stationary at this point, we cannot really tell, because there are some functions that it will be stationary at two different points. Like for example, this kind of function that we have here, stationary at two different points. Now how would you be able to tell if it is maximum or it is minimum at that point? Now for you to be able to tell further, then you have to differentiate the second time. Now by the time you do the second derivative and it is greater than 0, then it is minimum at that point. If it is less than 0, then it is maximum at that point. And if it is equals to 0, it's called the inflection point. The inflection point is just this point, the distance between, it's just like the equidistance between the two maximum and minimum, the point where the curve begins to change to the other side. That's the inflection point. It is usually used in AEM. I just hope I have time to be able to cover enough of AEM in the future. Okay, now how do we apply this? We already know that it is stationary at where x equals to -2, right? But we cannot really tell if it is the maximum or the minimum at that point. In order for us to be able to tell, we have to differentiate this again. The first differentiation that we got was this. Now we have to differentiate again, which is what, 2. Now we see that it is 2 and it is greater than 0, then we can tell that it is what, minimum. It is minimum at where x equals -2. So it means the turning point is minimum at that point. It is something like this at that point. I just hope I've been able to, you know, teach one or two on this topic, and I'm going to move on to the next one as soon as possible. Thank you very much, and sorry I just recording this on the fly. It's not so coordinated, and just manage it. Thank you.